In this Learn, we'll do lesson 1.7, linear inequalities in one variable. Here are the objectives. You can pause, read them over. Our next slide, again, pause, read it over. But the key here is our inequality signs as opposed to an equal sign. These are linear inequalities when the variable is to the first power. Now, for example 1, again, pause, read this over, but let's go over it. If I say that 2 is less than 4, we know that's a true statement. Now, how about if I multiply this side by a 2 and this side by a 2? We now get 4 is less than 8, and that is still true. But when we're dealing with inequalities and we are multiplying or dividing by a negative value, watch what happens. A negative 2 times 2 is negative 4. A negative 2 times 4 is a negative 8. And is negative 4 less than negative 8? And the answer is no. So in general, and I'll use my eraser, in order to keep inequalities true, when you multiply or divide your variable by a negative value, to keep it true, you have to reverse the inequality sign. So that's the main difference in solving inequalities as opposed to solving equations. Otherwise, it's the same. Again, pause. Read this over. This is in writing what we've just commented on orally. All right, going on now to example 2, if you're noting numbers, and this is part A. We've copied down what we have here, going to the whiteboard, and if we didn't have this inequality sign, this would be a typical equation. We'll keep our inequality sign under each other. We're going to get rid of grouping symbols here. So this is 5 minus 2x, distributing that, plus 6 is less than or equal to. Now I put in a negative 1 here because you're just going to distribute or remove the parentheses and just change the signs. This becomes a negative 1 and this becomes a plus x. So we group like terms. This is going to be a negative 2x plus 11 is less than a negative 1 plus x. Now there's two ways to do this, and eventually I'll show both ways. But you may recall I've said it's a good idea to keep your variables positive. So keeping that in mind, I'm going to move this negative 2x to this side where it becomes a positive 2x. So this is now 3x. I'm going to move this negative 1 to this side where it becomes a positive 1, and 11 give me a 12. Now notice that since my variable is positive, I'm going to divide by a positive 3. Now, because I'm using a positive, I don't have to change the directions of my inequality. So this just becomes x is 4. But notice we like to read these from left to right, where our variable is on the left. So I'm just going to reverse this. X now is greater than or equal to 4. Notice positive x, you read it this way. The open part of the inequality sign faces the x. Now let's graph that. The number we're interested in is 4. Now, what sign do we use? As you put this into the software, in order to put greater than or equal on the number line, I have to choose a bracket to include 4. If it was only greater than, I'd use a parenthesis here. And this goes on to positive infinity. And we would just fill that in. Now, they want the answer in interval notation. So how do I put this in interval notation? Well, so easy from the graph. We're going to use the bracket. 4 is included, comma, and out here is positive infinity. Now, infinity always ends up with a parenthesis. So this would be the answer in interval notation from this. Now, had I moved my x value to this side, it would have become a negative 3. I would have had to divide and reverse the sign. So in a sense, I'm doing that, but we'll show the other way as well. All right, let's go to the whiteboard and check things out, or from the whiteboard, I should say. And we see it here. Now, notice the way they solved it. They used the other method of putting the negative on this side. In order to keep this correct, they had to reverse the inequality from less than or equal to greater than or equal, and then in interval notation. Now, usually they ask you to graph these. Here they haven't, but that is often an option. All right, I've copied example B. We'll go to the whiteboard. Now, that same technique of getting rid of the fractions is a good idea. So I'm going to put a big set of brackets here. And this is one term because of this division bar, and this is one term. My lowest common denominator is 4. So dividing or doing this multiplication, 2 goes into 2 once. 2 goes into 4 twice. I'm going to leave the 4 there. And I just have to multiply this by 2. Here, 4 goes into 4 once, and there's no change. So this is then going to be 6 times a minus 2 is less than 5a. So 6a minus 12 is less than 5a. Again, I keep my variable positive, move the 5a to this side, becomes a negative 5a. And I don't know why I put an x there, it should be an a. This then becomes just an a. Move the negative 12 over, it becomes a positive 12. And there's my answer. Again, putting this on a number line to graph it, I'm interested in the 12. It says a is less than 12. So I'm going to use a parenthesis. And it's coming from negative infinity putting that into interval notation, negative infinity, comma 12, using the parenthesis. Again, the 12 is not included in the sets. Let's check this out. Pause, move it down, and there's the work, and it checks out. Again, you can always pause. Okay, if I looked ahead, they would show the graphical representation of our interval notation. So pause, read it over. Now in example 3, they're featuring graphing. And let's make this one big. So it's bracket, negative 3, comma, 6, bracket. So our numbers will be a negative 3 and a 6. And again, taking it from interval notation, we're going to have a bracket at negative 3 and a bracket at 6. And then we just fill it in. And there is the graph of this interval notation. Now for B, we have a negative infinity. Again, we always have a parenthesis for negative infinity and a 5 with a bracket. So again, negative infinity is coming from there, and it's going up to 5. And from our interval notation, we're going to use a bracket. And there is its graphical representation. And you see it here actually too. All right, for C, we have a bracket 2, comma 9 with a parenthesis. So again, we're interested in a 2. We're interested in a 9. Now the 2 has a bracket, and the 9 has a parenthesis, and we fill it in. So pretty straightforward. We showed you how it's done, but let's just look at the graph again here. There you go, nicely done. As we continue, we're looking at solving double linear inequalities, often referred to as compound inequalities, and working with the words and or. And the word and is a conjunction, and both must be true. The word or is a disjunction word, and one or the other or both may be true. So again, pause, read this over, and I'll raise it up. Now, a person is doing this exam. There are going to be 5 exams. They have these scores so far, and there's going to be a 5th score that's unknown, so we'll use the X. And to get the average of these, I have to divide it by the number of items, which is 5. But they want the score to be greater than or equal to 80 and less than 90. Now notice the different inequality signs. So this is an N here. And we're going to calculate this. And rather than my writing it all out, let's just follow it through here, step by step. let's work from here. So we want to get rid of this 5 here. I would do that first. Okay, they're doing it a little differently. There are different ways to do it. So I'm going to multiply everything by 5. That'll get rid of this fraction right there. So 5 times 80 is 400. Now when I multiply this, and it's one term because of the grouping symbol, by 5, the 5's just cancel out here. So I end up with the sum of this, which is 307 plus the x, which they're showing here, and then 5 times 90 is 450. So how do I get the x by itself? Well, I'm going to subtract 307 here, subtract 307 there, and subtract 307 there. Now I'm doing the same thing to each part of the inequality. Here this just becomes a 0, so I'm left with the x. And here I'm left with 93, and here 143. Now, generally when you take a test, you don't get 143% on a test. So what we're particularly interested in is the 100. So, and notice the 100 would be, we've changed this inequality sign here to a bracket. Here it would have been, if you put this whole thing, this would be 143 there, but we're not interested in that part. We're saying this is what our solution would look like. All right, pause again, read it over. Okay, on to example 5. I've written A up. Let's go to the whiteboard. Again, solving it is very much like an equation. I want to isolate the x term in the middle here. So I'm going to subtract 3 there, subtract 3 there, subtract 3 there. Then this becomes a negative 4 is less than negative 2x is less than or equal to 2. So again, this just cancels out. Add these up. Now to get rid of the negative 2 that's with an x, and I'll change colors here, I'm going to divide this term by a negative 2, this term by a negative 2, and this term by a negative 2. And you might say, wait a minute, I'm dividing by a negative 2. Don't I have to change my inequality sign directions? Yes, I have to reverse them. So this is now going to be greater than. This is going to be greater than or equal to. And you can see here I'm going to end up with a positive x. This cancels out. A positive 2 here and a negative 1 there. Now for few students this might be all right like this, but for most students I think having the lesser value on the right, that would be a problem. So strongly suggest you rewrite this with the lesser value over here on the left. So I'm going to put negative 1 there. But where do I put my inequality sign? Has to be pointed toward that negative 1, like so. The x stays the same, still in the middle, and now I have less than 2. Okay, let's put that on a graph. The numbers I'm interested in are a negative 1 and a 2. Now what sign do I put here? Parenthesis or a bracket? a bracket, and here a parenthesis, filling it in. And then in interval notation, what do I have? Again, bracket, -1, comma, 2, parenthesis. And hopefully you know what that means. 2 is not included, but the -1 is, and what's in between. All right, let's check it out here. Go back. And notice they did what I suggested. Go from this form to this form where the lesser is on the left and everything checks out. All right, let's do part B. I've checked that I copied it correctly, and we'll distribute first. So this will be 4x minus 2 is less than or equal to 4x plus 2 is less than or equal to 4x plus 4. Now, again, this looks a little strange because notice as we subtract out 4x, we get -2 is less than or equal to 2 is less than or equal to 4, which is a true statement, but we don't have variables anymore. So what is the solution for something like this? Well, it's all real numbers. And we would indicate that from -infinity to +infinity would be the answer. And let's go back and check it out. And that's what they're saying. Pause for a moment to read what they're saying. Continuing, we're going to take a look now at the solving linear absolute value inequalities. Now, it's critical, again, that you pause and read this over carefully. We did refer to this a little earlier, but pause, read the upper part. I'll raise it up and we'll do the bottom part. So, two things to remember, and I'll emphasize that here. That if you have the absolute value and the inequality sign is less than, this is the word and. That is, both must be true. And if you have x is greater than, you're going to have a condition that is an or, where either of two inequalities must hold. So reading this is important, and then seeing it as we have shown here. Let me raise it up just a little bit more. There we go. And they're showing you what, and let me give names to this. You might add this. This symbolism is a conjunction. And this symbolism represents a disjunction. Disjunction is associated with or, either or both. Conjunction, both must be true. Another way of looking at this this is an intersection, and this would be a union in set symbolism. So we're giving you some background. Now, as we look at these examples, it will be critical to pause and reflect on what we've just gone over. So as we look at this, is this going to be an and or an or? Well, it's greater than, so it's going to be an or, something to keep in mind. So let's write it out without the absolute signs. We just write it like so, just like we were doing equations. Now this is an or. So now we write it again. But now we're going to change this to a negative, and we need to reverse this inequality sign. So there's the key of getting the correct answer. Writing it, just remove the inequality signs. Since it's greater than, it's an or, and we reverse that and put a negative there. Now we just solve it. So this is going to be, and again, I'm going to move the negative to this side. So I get a positive 2x. That way I don't have to reverse the sign anymore. In a sense, that's what I've done here. Bringing this over becomes a negative 6, so this is a negative 2. Divide both sides by 2. I get a negative 1 is greater than x. And then to write that, x is less than negative 1. We've got that one done. Now here, again, I'm going to move this over. This becomes a positive. Or let's do it the other way, just for the sake of doing it, to show you. Again, there's different ways for it to be done. So I'll have a negative 2x is less than, bring this over as a negative 4, so this is negative 10. I'm now going to divide by a negative 2. Since I divided by a negative, I have to reverse this inequality sign. This now becomes x is greater than 5. All right, let's put this on a number line. There's our negative 1, and there's our 5. Now it says x is less than negative 1. So we're going to use a parenthesis at negative 1, going off to negative infinity. And at 5, we're going to use a parenthesis going off to positive infinity. So how do we write this? Remember, this is an or, a disjunction. Well, we're going to say from negative infinity, this one, up to negative 1, parenthesis, negative 1's not included, and then we use the union symbol from sets. It's going to start at 5 and go to positive infinity. All right, let's check it out and see how we've done. Good, everything looks good. And if I go down, we can actually see the graph here, and we did good on that. This is running a little long, so I'll just use the book, and we'll go over B here. Now, again, by inspection, this is less than or equal to. So this is going to be an and. as opposed to an or. So it's where they are intersecting. So the first thing they're going to do is take this 3 here, subtract 3 from both sides, and then divide both sides by 2, and you end up with a 4. And again, since this is an and, they're writing it up as a conjunction. They're going to add 2 to both sides and the middle. Get this. And then eventually end up with this. So putting this in interval notation and then graphing it. All right, I went through that a little quickly. Again, pause and work it out. Now, I'll use the book for these next 2 as well, pointing out what I think are the highlights. Now, normally we said that if we had the absolute value of something, and that was equal to a negative value, there would be no solution for that. But now we have to modify that just a little bit when we're doing inequalities. And let me point that out to you. Let me erase this. And if this is an and less than or equal to, that is an and, which is a conjunction, then that is true. There are no solutions for this. But if, and this is critical, just have to study this. I'll erase this. And we're looking at D now. This is greater than or equal to, and this is an or, which is a disjunction. This is not only possible, but the solution for anything that looks like that, which we see here, is all real numbers. And of course, that's negative infinity to positive infinity. Okay, 2 little areas that need some particular study and are a challenge should you run into them in your practice and certify. And we're almost finished. But this one, you need to, again, read and note these ambients here, the translating inequality phrases. Sometimes it's only less than, sometimes only greater, but sometimes greater or equal, less or equal. Check it out. Again, pause, read it over. This is our last slide, our last example, example 8. Again, there's lots of reading. Look it over. How are you going to choose to do this? All right, let's move it up a little. And we can look at A here is worked out for us. This is your left side of your inequality, and it would be exceeds, so is greater than 75. So in this case, x would be greater than 76 degrees. Again, pause is needed. Read it over. And then this is the last one. Now, throughout these, of course, the learn that I'm using are from the textbook. This is sort of like an oral review of the textbook material, and where I'm helping you, you are the ones learning, and you learn through your own initiative. The teacher guides somewhat. Okay, we'll wrap this up. It's quite long and hopefully helpful.